I'm gonna try to be lickety split with this, but we'll see what happens. Okay, so normally what you would do to try to determine if a function has a relative minimum or relative maximum, also like a relative extrema, um, using the derivative is by finding the first derivative, discovering where the first derivative is equal to zero, and then seeing on like graphing out a sign chart and trying to see if the at that point the function changes from positive to negative or negative to positive. And I'll do that real quick with this here. Actually, let me make a new thing. Sorry. So what we do with that is we just find the first derivative. Um, Set that equal to 0 and then find the points where wait, whoops. Where this derivative is equal to 0 is going to be at x equals 0 and x equals negative 4/3. Now I could like show you the whole do the whole sign chart thing, but I'm confident that y'all know how to do that because you've done it a lot. You can also just plug it into your calculator. Like if you put just 3x squared plus 4x, 3x squared plus 4x, the first derivative, you can see that it's positive. Oop, positive, it changes to 0 at negative 1/4, and then it's negative and changes to 0 at 0, and then becomes positive again. So when there is a sign change from negative to positive or positive to negative, on the first derivative, that indicates that there is either a relative maximum or relative minimum. You can't remember how to determine that. Remember that the first derivative being negative means it's decreasing, and it being positive means it's increasing. So if it's negative, down will go up, and so that means a minimum. You can figure it out by just imagining it conceptually. But there's another way to do this that is not harder. It's actually also pretty easy unless you have a crazy problem. But if that happens, remember that you can always plug it into Desmos. Just plug in f of x, f prime of x, and f double prime of x, and put in all your stuff, and you'll be able to determine everything that way if you get something super crazy because we have Desmos. But still, the tricky part about this is that it's really forgettable and that the last part of the thing is really easy to forget. So you start out with the second derivative test, you'll start out by doing like the same way by finding your critical points. So we once again just find the first derivative where the first derivative equals 0, which we found was x equals 0 and x equals negative 4/3. Okay, so the next thing that you do with this is you find the second derivative and just do that normally. Double prime of x to 6x plus 4. And now, okay, so what you're going to do with this is you're then going to plug in your points of potential extremas, your critical points, into the second derivative equation. So f double prime of 0, I'll do first, is equal to 6, 0. I'm going to solve this one out real quick, but you don't actually need to solve it all the way through. You just need to figure out if your output, which is 4 here, is positive or negative. Because the second derivative test basically says that if f double prime of x is greater than 0 at the critical point, it is a minimum. So basically, if your output here is positive, it's a relative minimum. So at x equals 4, f has a relative, and then for same type of dealio for f equals negative 4/3. Mm, It's negative 4/3. So negative 8 plus 4 will come out to negative 4. And since it's negative, since f of x is less than 0, or sorry, f double prime of x is less than 0, the critical point at where f of x is equal to 0, basically saying that number is negative, there is a relative, oh wait, sorry, I messed that one up earlier. There is a relative maximum x equals negative 4/3. Ignore that. You don't need to figure out this number here. Oh, sorry, this number here again. You just need to figure out if it's a positive or negative value. And you can just say in your equation, like if you were proving this, you would say there is a, let's do for this one, there is a relative maximum, or f of x has a relative maximum at x equals negative 4/3, as f double prime of x is greater, or sorry, is less than 0, and f prime of x is equal to 0 at that point. Something like that. I hope that helps.